Hi, I'm Ethan Keller, and I'm going to show you how to use OnShapePy. So here's my terminal. I'm going to install it through pip. It's always a good idea to make sure you're getting the latest so that you don't get a cached copy. Just use the dash capital U. Okay, we have 0.0.7. Now, let's start a Python. And the first thing is to specify your API key. This is what gives OnShapePy access. So we do that by making a configuration dictionary. And this is what the entry has to look like. So you can get this access key and the secret key by going to dev-portal.onshape.com/keys and then just say create new API key. So I'm just giving all access to all, but you could change that as needed. Okay, now copy your access key. I'll be deleting these access key and secret key. So obviously use your own, don't copy these. And the secret key is right here. That looks right. Okay. Now I've made a convenience import here. It's called OnShapePy.play. So you just import star from that. And that's good for interactive sessions because it sets up your interpreter pretty nicely. So now, to get a handle on a particular OnShape part, you can use the part initializer. And here I'll show you the part that I'm going to be using. So it's this cube, and this cube has 5 different configurations. So it has length, height, width. It has a Boolean option here, whether it has a fillet or not. And then you can choose between different fillet types within that fillet. So the configuration is kind of all that OnShapePy has access to. So once you change the configuration, that's kind of how you define the interface between OnShape and your Python code. And because configurations in OnShape are so powerful, that gives you almost unlimited access to how to define the geometry of this part. Now, we also support measuring in OnShapePy, kind of limited right now, but you can measure between 2 points, and then as the configuration changes, so will the resulting measurement. So for instance, I've got this diagonal 3D. Let's see what that is. So you can see it is a 3-dimensional diagonal from the most extreme points in this cube. So, and I'll show you how to get that value within OnShapePy. Okay, so the first thing to do is collect this URL and paste it into the part. Okay, so now cube is connected to that part. So if we do cube.params, for instance, you can see the current params. There's a length is 100 millimeters, height is 100 millimeters, width is 100 millimeters, as fillet is true, and fillet type is circular. So now begins the fun. You can do cube.params equals, and you can specify as many or as few as you want. So for instance, has fillet, is false. So if I do that, now you'll see it turned off the fillet. Similarly, we use pint units, so I'll show you how to input a unit if you want to change the length, for instance, to 170 millimeters. You use u dot millimeter. So you can see that changed the length. So you can access any of the params like that on the fly. If you're changing a bunch at once, you'll want to put all of those changed ones inside a single dictionary call. So you can assemble the dictionary outside and then push it to cube.params. And when you set this parameter, all of those will change in one server call. So let's just show what that looks like. Let's change this to 300 or 1300 for u dot millimeter. I believe the u dot also supports mm. So here, this is going to turn it into kind of a disk, because I'll have this be just 10 millimeters tall, and we'll see what that looks like. Yeah, so it's a pretty thin thing, so you can see the configurations updated accordingly. And now lastly, you can see that the diagonal will have changed, because it's still pointing to those 2 points in the extreme end. So to get the diagonal, we do cube.measurements. And you can see I record both a diagonal and a diagonal 3D. So the diagonal is just between one side, the bottom, and the diagonal 3D is from the most extreme 2 points. So now I can show you how to use something like NumPy in this. I have a notebook set up here, which every half second calls to change the params to a random number between 0 and 1 multiplied by 300 millimeters. So if we play this, the cube should kind of dance. I'm going to set this back to the standard, which is 100, 100, 100. And now let's see this cube dance. So if we run this, you can see it's kind of randomly jumping around here based on the NumPy values. And you can see the diagonal also updates accordingly. Yeah, so that is how you can use NumPy, and you can imagine using this for far more complex scenarios. Have fun.